Okay. 3, 2, 1.
Hello, my name is Tyler Nolan,
And my name is Noah Barron.
and this is our presentation on our innovation of track spikes.
For us to be able to accomplish our goal of our innovation of track spikes, we have to follow the 6-step engineering process. The first step being to define and justify a problem. And our second step is to research solution concepts. Research is a major portion of this project. Third step is to brainstorm solutions. And our fourth step is to develop a prototype and a testing plan and to execute that testing plan with our prototype. And our fifth step is to reflect.
Point it to the screen.
To reflect on the solution and the design process, figure out what went right and what went wrong, and if we need to go back and fix anything. And the sixth step is going to be us to present our project findings to a board of engineering experts. Now, where are we in this big, long chain of events? Well, we broke this down into smaller, more manageable steps for us to be able to do, with the first being to define a problem. And we did this through various activities, and we actually got assigned our partner through this. After we defined our problem, we moved into validating our problem. Like I had said, research is a very, very vital part of this project, and we will be going more in depth with this later in this presentation. And to help validate our problem, we moved into a market research. We made a 20-question survey where we surveyed our audience to figure out what they want, to help us figure out the criteria of what we want, and just assisting us in figuring out what's going on. And then after that, we moved into looking at existing solutions. And we figured out that if our product can compete in any other category, in all these other categories, and be easily replaceable, we are going to be very, very competitive in this marketplace. And then we moved into business planning, figuring out when our product is made, how are we going to approach this from a business standpoint. And after we planned for business, we moved into problem proposal, where we're going to take this to potential investors and tell them about our problem. Now, my partner and I have just finished up our criteria research through the assistance of our market survey and various other research. And we are now starting to brainstorm solutions where we will be sketching and thinking of any way that we can possibly fix this.
So one of the first tasks Noah and I were presented when we became partners was designing and developing a problem statement. Our initial problem statement, as you can see, one interesting part to know about our initial problem statement as you read through is we said that the problem was in the bottom of performance racing shoes. Now, when we presented our problem statement to other experts and other future engineers, they told us that this problem isn't just defined in athletics such as track and field and cross country. We were told by other athletes that this problem is seen in many other sports, including baseball, football, soccer, etc., and even golf. So when we created our second problem statement and moved on to our final problem statement, we added that this problem is something that is seen in athletic shoes, performance athletic shoes. And that's one thing we really wanted to touch on in transitioning from our initial final problem statements. Other things we hinted on while changing our problem statement over time was we knew that because track and field and cross country isn't something that the general public knows completely about, we need to be descriptive in what our problem was, because most people may not experience this problem on a day-to-day basis. Also, in moving from our initial to final problem statement, you can see that it was shortened a little bit because we read our initial problem statement and figured that while it was detailed, it was a little too extensive and could be confusing because of how long it is. During our research, we were very, very fortunate to have plenty of sources to help us gather information about this problem. This graph here, you can see, is an artifact from a study done at IUPUI. We were fortunate enough to go and meet Dr. Bahamadeh from IUPUI, who performed this research, and he was able to describe to us a little what went on in his research. So as you can see here, what many people do not know is that there are different geometries of track spikes and the shape of the spikes that are screwed in the shoes. A few of them are defined here as the modified tree spike, pin, post, pyramid, and tree spikes. Now, those may not mean a lot to you, but the data here can mean a lot. So this data is based on energy return of this different geometries of track spikes. Now, when you think of a runner running on a track, as their foot hits the ground, the rubber on the track is going to compress and then bounce the runner back, giving them energy back to their foot to help them propel forward. Well, what Dr. Mohammadeh described to us was that the modified tree spike was a lot like a large man jumping on a trampoline. As the large man jumps on the trampoline is compressed, and as far as that trampoline is compressed, it then extends back, propelling the energy to the man to propel higher. Now, if you think of an icicle that is the exact weight of the man falling onto the trampoline, the icicle will fall onto the trampoline, but it won't compress and bounce the trampoline back. Instead, it will pierce the material of the trampoline and cause no energy to be returned to the icicle. The icicle is a lot like the pin, as you can see here, which has very low energy return on average, because the pin spike often pierces the track as you run along, providing little to no energy return to the athlete. Noah and I knew that when we created our design, we need to make sure that we don't mess with the geometry of the track spike, as it provides heaps of help when it comes to running events, whether short distance or long distance, and the energy return provided. After researching artifacts, we moved on to patent research. We were fortunate enough to find many patents from many different sources, some even from popular companies that you may know, such as Nike and Adidas, and a few from Adidas's founder, Adi Dassler, years ago. After researching patents, we then moved on to already current products that attempt to solve this issue. As Noah stated earlier, with our previous solution matrix, we found that through researching already existing products, that our product can be extremely marketable in this market if we make sure our product is meeting the exact standards already presented by current solutions, while also being easier and faster to replace, because that's the problem that consumers are facing nowadays. We then moved on to the market research portion of our research. We developed a 20-question essay that we sent out to track and field athletes, both current and previous athletes. And we initially started by sending out to athletes in the region, in the Hoosier Crossroads Conference. We were able to send emails to coaches of these teams, such as Zionsville and HSC, and those coaches were able to distribute our survey to their athletes, who gave us vital information on how much they experience this problem on a day-to-day basis. After getting research from the HSC conference, we knew that we needed a lot more research in order to really make sure our data was reliable, especially at a standard of across the nation or across the world, instead of just in central Indiana. We were very fortunate to be able to partner with Robert Johnson, co-founder of Let'sRun.com, an extremely popular running forum on the internet. Robert Johnson was able and willing to put our survey on the front page of his website, and overnight our results quadrupled. We went from a little under 100 results to over 500 results in just a matter of 48 hours. As you can see, we were able to verify that this is indeed a problem, as over 75% of the population that took the survey admitted to having an issue replacing a spike. And also you can see here that we got results nationwide. Any state that is blue denotes anywhere from 1 to over 30 respondents from that state, with high respondent numbers coming from California, Indiana, and New York. We're also very fortunate to gather survey respondents from international areas, such as Europe and even Australia. One of the really cool parts of our market research was, because Robert Johnson was able to post our survey on his site, we got feedback on our survey, not just on how this is an issue, but also on how to develop a survey. People were able to comment on the post of our survey, and from those comments we learned a lot, such as how certain questions we asked were confusing due to the wording. And also we even found that certain demographics of people may have been offended by our survey due to the fact that they felt as if their demographic was not properly represented in the answer choices provided. Now, because we had so much data to be able to gather through experts and market research and other things we found online, time management was an extreme difficulty. With all this research comes a lot of documentation. And so for Noah and I, it seemed to be a struggle at times to keep up with all the information we had coming at us and to keep it written down. Also, Noah and I are involved in many other activities outside of school and also in this class. So time commitment was also a struggle, as we had other commitments outside of this class.
throughout our time going through this design process, we have learned quite a lot. And documentation being the number one. As you can see by the picture here, our binders are thick because, like Tyler had said, in time management, with great opportunity comes great responsibility because we have so much paper and all this stuff that we can keep track of, but we have to be able to keep track of it. But it is very nice for us to be able to just put it in a binder, and if we need it, we just look at it and we're like, oh, that's the pattern we need, we look for it. And another part is we have to keep a website constantly updated of updates of things that are going on in the class, in our project, and it's overall a big learning experience. Another major learning experience is that we have a year-long partnership. In any other class, we would be if Tyler and I have a disagreement, we would just say, well, it'll be over in a week, but the thing is, this will be over at the end of the year. So if we have a disagreement, Tyler and I talk it out. The final thing that we've learned is the importance of community service and just understanding that what it means to be an engineer out in the community and for people to see you out there working for them. Now, like Tyler had said earlier with our meeting with Dr. Bahamande, he taught us a lot, and we got a lot of information from him. And I know, especially for me, he helped me out a lot because like Tyler had explained how the track spike acts like a trampoline, I never had thought of that. And then when he explained that, my mind was just blown. It was amazing.
Another one of our more recent experts that we have contacted is Mike Walker, who is the Vice President of Development and Design at Omnilight Industries. Omnilight is the world leader in replacement track spikes, owning over 80% of the market. Now, Omnilight provides the spikes that Nike, Adidas, and some of these other companies put into their shoe boxes for athletes to get off the initial purchase. We knew that we should contact Omnilight, since they were the world leader, to just figure out what standards their spikes abide by, to know that what our spikes should abide by should we follow through and create a design. We were fortunate enough for him to send us actual blueprints of the spikes that Omnilight creates, and as we move forward into the design phase of our project, we will definitely be using those blueprints to help create our design. Community service is, again, a big part of this project, and Noah and I have thoroughly enjoyed our time with the community. As you can see on the right there, that is me at a field day with the athletic ambassadors, getting to go out with a group of athletes, Noah and I both being in that club. We get to go out as a group of athletes and teach some of the third graders about different character traits throughout the month.
Yeah, like Tyler had said, community service is a major part of this, and here is pictured me at what is called Amazing Grace at my church. We go to a little church that's on the outskirts of Indianapolis, and it's kind of a struggling part of the city. And what we do is we just go there, we have some fun with some kids, we feed them, have a meal with them, and just give them a message and just have some fun with them.
And then finally, here on the left, you could see me directing a biker as I volunteered at a triathlon where I stood at a street corner and make sure the bikers went the right way and cheered them on towards the finish.
Now, what to look for, because we have to complete this process. Once we finally sketch our plan, we're going to construct a testing plan. After we construct our testing plan, we will move into constructing the prototype. After we have it all sketched, we will then construct our prototype. And then we will execute through the testing plan with our prototype. And after we test our prototype, we will then reflect on the test, figure out what went right, what went wrong. Did we miss something? Are we forgetting that our audience needs this? And did we solve the problem? And then we will go through the process of reflection of the design process overall and figure out how did we do. And finally, we will present our project findings to our engineering experts.
Noah and I are very excited about the future of this project, and we look to even manufacture a prototype for us and other athletes to use in actual competition this coming track season. Is there any questions anyone would like to answer? Yes, John.
So I know, I'm in the marching band, and there's a lot of regulations about what can and cannot be worn during a competition. Are there the same rules in in track competitions, is that like a regional thing? I know that there are like regional events or national events. What's the rules regarding those?
That's a fantastic question. Noah and I had that same question going into our initial research. As you may have seen in our experts and mentors, we were able to contact people at the United States Track and Field Association based out of Indianapolis, and they were able to answer that question for us. One of the things we learned is that the USATF and other governing bodies do not actually define the regulations for what shapes and geometries of track specs may be used. That is actually defined by the manufacturers of the track surface itself. So there are some legal issues involved with the warranty of the track surface and things of that nature. So those manufacturers have defined what geometries can and cannot be used based on how much those geometries can deteriorate the track surface.
And that's all the time for questions we have. Thank you.